Okay, in this lesson we're looking at Unit 4, Chapter 4, Trigonometry in a Unit Circle. We're going to be solving trigonometric equations Part 2, and we're going to be solving trig equations by factoring this time. As I said, the focus is going to be on solving trig equations by factoring. Certainly the more complicated type of trig equations, very good chance you will be asked to factor one on your public exam. Very good chance. I've got 3 examples to do. Here's my first one. Factor to solve the trig equation. Solve for theta. Tan squared theta subtract 5 tan theta plus 4 equals 0 between 0 and 2 pi. Give solutions as exact values where possible. Otherwise, we give approximate angle measures to the nearest thousandth of a radian. Okay, the first thing I'm going to do is I'm going to consider the equation tan squared subtract 5 tan plus 4 equals 0. What I normally do here, to simplify the equation, I'm going to let tan theta equal m. I just choose a variable. So that at tan theta equal m, I can rewrite this equation as m squared subtract 5m plus 4 equals 0. When I do that, it's pretty easy to recognize this now as a quadratic equation that we should be able to easily factor. When I factor this, I'm looking for 2 numbers that got a product of 4 and a sum of negative 5, which of course would be negative 1 and negative 4. I use my zero product property and I do m subtract 1 equals 0 and m subtract 4 is equal to 0. And I get m is equal to 1 and I get m is equal to 4. And I'm certainly not done here because I'm not asked to solve for m, I'm asked to solve for theta. And we need to remember that we let tan theta equal m. So I'm going to go back and replace my m with tan theta. So therefore tan theta is equal to 1 and tan theta is equal to 4. Now I need to consider both of these equations. Tan theta equals 1 and tan theta equals 4. I know that tan theta equals 1 is a special angle because I know that tan is positive in 2 places. Using my CAS rule, tan is positive here and here. And I know that the reference angle for theta is pi over 4. Reference angle for theta is going to be pi over 4. Now I know that because the coordinates of the point associated with pi over 4 is root 2 over 2 and root 2 over 2. And if I divide sine divided by cosine, which is tan, I'm dividing root 2 over 2 divided by root 2 over 2, which is 1. That's how I know the answer for theta here is pi over 4. So if I'm looking for my values of theta between 0 and 2 pi, then tan theta equals 1. I'm going to get one answer at pi over 4. And I get another answer at 5 pi over 4. And if you look closely where I got that, you can see pi over 4 is one answer. The other answer is right here for theta. Maybe I can draw that in for you. That angle right there is 5 pi over 4 because it's 4 pi over 4, which is pi, plus 1 pi over 4, which is 5 pi over 4. So I got 2 values for theta between 0 and 2 pi, and they are exact values. Pi over 4 and 5 pi over 4. I immediately recognize tan theta equals 1 as a special case. And it's a case when theta is equal to pi over 4. Now what if tan theta equals 4, however? If tan theta is equal to 4, this is not a special case. I have no other choice but to use my calculator to figure out the values of theta. But I still need to consider the fact that tan theta is equal to positive 4 in 2 places. I can't forget that. Tan theta is positive in the same 2 quadrants that it was a minute ago, of course, right here, right? So tan theta is positive in these 2 quadrants. And I need to use my calculator now in radian mode. So I'll change the mode here, put my calculator in radian mode first of all. And I simply do second function tan of 4. And I get an answer of 1.32 radians. So theta equals 10 to the minus 1 of 4, and I get theta is equal to 1.326 radians, because it did say to the nearest 1,000 up right here, right? My calculator gave me this answer right here, 1.326 radians. So that's my third value of theta, because I've already found two values over here. My fourth value of theta is right there. So I need to figure out what that value of theta here is. Well, that value of theta is going to be 3.14 plus the reference angle, which is 1.326. So I'm going to do pi plus 1.326, and I get 4.4676. 4.4676. Well, I don't need the 6 because I only had to go to the nearest 1,000. So I guess we'll make that an 8 there, I guess. Change this here. A second. So to the nearest 1,000, it'll be 4.468. And the reason why, again, I added my 1.326 is because my reference angle right here is exactly the same as the reference angle over here. So that reference angle there is also 1.326. So I added pi to that to get my fourth value of theta. And I got the question done. Let's have a look at another example. Very similar, but this one involves sine. I got 2 sine squared theta equals sine theta plus 1. If you want to factor it, you got to get it equal to 0. So I'm going to do 2 sine squared theta, subtract sine theta, subtract 1 equals 0. Again, I'm going to let m equal sine theta so that it makes it a little simpler. That's all it does. And I get 2m squared, subtract m, subtract 1 equals 0. Now again, I'm going to factor this equation. To factor that equation, there are many different ways of factoring. Some of you, I'm sure, use decomposition. Some of you may use the method I use, which is trial and error. And some people may even use the box method. I'm going to use my own method here, which is simply multiplying 2m by m, 1 and 1 here, and I use trial and error method, you see, and I want to get a negative 1, and I want to get a negative 1m, so if I did that, that's going to give me a negative 1m. I'll quickly check my work by using the follow method. 2m times m is 2m squared. 2m times a negative 1 is a negative 1m, plus 1m is a negative 1m, and a plus 1 times a negative 1 is a negative 1. So I know I got to factor correctly. Again, some of you may not factor that way. Some of you may use decomposition. If you need to do that, you go ahead. But I got the zero product property again. So I got 2m plus 1 equals 0. And I got m subtract 1 equals 0. Therefore, 2m is equal to negative 1. M is equal to negative 1/2. And m is equal to 1. So, of course, don't forget that m is sine theta. So I got sine theta equals negative 1/2. And I got sine theta equals 1. I need to consider both of these equations, so let's do them separately. Let's solve sine theta equals negative 1/2, and let's solve sine theta equals 1. I do need to do both of them, because I have two solutions. Sine theta equals negative 1/2. Sine is negative. Got to consider where sine is negative. Using the cast rule. Sine is negative in, draw your terminal arms here, these two quadrants. Now, sine is negative 1/2. You need to think about sine being the second coordinate, being negative 1/2. So if sine is the second coordinate, you should recognize the first coordinate as root 3 over 2. Sine is the second coordinate of 1/2. Same thing will happen over here, of course. It's going to be negative root 3 over 2. And positive 1/2. So sine, sine is negative, so it should be negative and negative, of course. Sine is negative in the same two quadrants, which I've highlighted, which is fine. It's just that I forgot to put in the correct sine here. So sine is negative 1 over 2. Now the reference angle associated with that point, you should recognize is 30 degrees. And I'm looking for my answer in degrees this time. So my reference angle is 30. Reference angle is 30. So my two values of theta between 0 and 360 are going to be theta 1. You should recognize it as 210, which is this angle right here. And the second value of theta is this angle right here, which you should recognize as 360 minus 30, which is 330. Okay, so I've now found two values of theta between 0 and 360, where sine theta equals negative 1/2. I got to do sine theta equals 1. Sine theta equals 1, we're going to use this circle that you see here. Sine theta is equal to 1, sine being the second coordinate right there, and only there. So sine theta is equal to 1 at 90 degrees. And that is the only answer between 0 and 2 pi, or between 0 and 360, where sine theta is equal to 1. So I have three values for theta, 1, 2, and 3. And that ends that particular example. Let's do one more. Now this time we're looking for the general solution. Determine the general solution of 2 cosine squared x plus cosine x equals 1 over the real numbers if x is measured in degrees. Again, we're doing it in degrees. Okay, 2 cosine squared. Again, I will let m equal cosine theta, or cosine x in this case, just to make it a little simpler when we go to factor it. So I get 2m squared plus m, subtract 1 equals 0. Again, I brought the 1 over to this side and subtracted it because I want to get it equal to 0 in order to factor. It's a quadratic now. I factor it again. 2m, m. Now this time I want to get a positive 1. So I'm going to use a plus 1 here and a minus 1 there. Let's check it. Check my factoring. 2m times m is 2m squared. 2m times 1 is 2m. And a negative 1m is a positive 1m. A negative 1 times a positive 1 is a negative 1. So I know I got to factor correctly here. So now I simply solve for m using the zero product property. And I 2m equals 1, m equals 1/2, and m equals negative 1. Now notice this time we're looking for the general solution though. Don't forget, of course, that m is cosine theta. So now we're looking at cosine x equals 1/2 and cosine x equals negative 1. Now where is cosine x equal to 1/2? Let's do again both solutions over right here somewhere. We will do cosine x equals 1/2 and we will do cosine x equals negative 1. Well, cosine x equals negative 1 is pretty easy to do if we look at our unit circle here. Cosine x equals negative 1 right there. And of course, that's at 180 degrees, because we are looking for an answer in degrees. So we see that 180 degrees is an answer. Now we need to consider, though, the general solution. We're looking for all answers where cosine x equals negative 1. How do I represent all answers? I write plus 2. Oh, sorry. I was going to write 2 pi n, but of course that would be in radians. I'm going to write plus 360 n, because we're doing this in degrees, where n is nominal of I. That will give me all possible answers where cosine of the angle is equal to negative 1. Now, where is cosine x equal to 1/2? Cosine x is positive, using our cast rule, in this quadrant and in this quadrant. Cosine is positive 1/2. Cosine is the first coordinate, with a reference angle of 60 degrees. You've got to recognize the reference angle with a point of 1/2 and root 3 over 2. So reference angle of 60 degrees. So you can see that I got two answers here for x. I'll call that one x1 because I did it first. I got another answer for x as I rotate. I got 60 degrees. It's going to be one answer. And I got another answer at, think about your angle of rotation as we rotate. I'll again highlight it for you here in the diagram. There's my one answer, 60. Here's the other answer, which you should recognize is, with a reference angle of 60, 300 degrees. Again, I'm looking for the general solution, so I need to say plus 360n and plus 360n, where n is an element of I. Where n is an element of the integers. And there are my three answers for x. Again, a note again that we had to factor, and when we factor, we usually get two equations that we need to solve. We need to solve them separately, and we need to find all solutions. Key ideas again. To solve a trig equation, which is what we were doing, algebraically, you use the same techniques you use in solving linear and quadratic equations. If that were a linear equation, we would solve it by factoring. It's a trig equation, we still solve it by factoring. When you arrive at sine theta equals A, cosine theta equals A, or tan theta equals A, you use the unit circle for exact values, which you saw us do, and inverse trig function keys on the calculator for appropriate measures. You use reference angles to find solutions in other quadrants. We did that. To solve a trig equation involving secant, cosecant, or cotan, you need to work with the related reciprocal ratios, or reciprocal values. In this particular case, we didn't have to deal with any of these, but sometimes you will. And to determine the general solution, which we did in the last example, you find the solution in one positive rotation, then we use the concept of coterminal angles to write an expression that identifies all possible measures. And that ends this lesson.